Welcome to this tutorial on how to use analogRead with the if and else if control structures. I'm creating this series of videos about analogRead and using various control structures for those who very likely have a piece of code, have already constructed a piece of code like this one, and are wondering, how do I go further? How do I do something cool with the values that I'm pulling in through analogRead, as well as a means of reference for a later set of videos I'll do on how to create things like an Arduino based volume units meter, a view meter, or a spectrum analyzer. How to truly complete a project like that from beginning to end. So this series of videos on analogRead with the if and the else if control structure, as well as the next installment using switch case alongside analogRead, are for those who are wondering how to do something cool with the analog value they're pulling in with analogRead, or as a means of referring back to for a later series of videos. That being said, let's just make a quick run through with this piece of code. First, in void setup, we have established a serial connection at 9600 baud. I've added in a brief delay just to give that serial connection between the Arduino and my computer a little bit of time to stabilize. Inside void loop, we are reading the values, the voltage values coming in on the analog pin 2, and what I have connected here is just a standard old potentiometer. The left-hand pin of the potentiometer is connected to 5 volts on the Arduino. The far right-hand pin is connected to ground, and the center pin is connected to the analog 2 pin on the Arduino. So when I turn the knob or the wiper of the potentiometer, it will vary the voltage values coming in on pin 2. It'll either be, if I go all the way to the left, it'll be 0 volts coming in. If I go all the way to the right, it'll go 5 volts. If I'm somewhere in the middle, it'll be 2.5 volts, around there. And all the voltage, that whole voltage range in between 0 to 5 volts. Well, what will happen is this analogRead function will pull in those voltage values, push them through the analog to digital converter inside the Arduino, and it will cast those voltage values from 0 to 5. It'll cast them in a range of 0 to 1023. So the conversion is from 0 volts to 5 volts. It comes in as 0 to 5, and it kicks out, or is assigned over to this integer type variable named analog value in the 0 to 123 range. So most people are familiar with this by now. And then all that I've done after that is I have a nice little message that the analog value, this value, equals, well, whatever has been assigned from that analogRead function. AnalogRead is going to give you an integer value between 0 and 123 based on, in this context, where the wiper in the center of the potentiometer or the variable resistor is located. And I've added in a brief delay just so we don't get blown out on the serial monitor screen when this code's uploaded. So we can upload this code and just see what the output is as we vary the potentiometer. So we can open up the serial monitor, and we'll immediately, well, I have it set at 0. So I can turn the potentiometer, and we can see that the analog values increase and decrease based on where I'm positioning the wiper in the potentiometer. I can crank it all the way to the right and max it out at 1023. I can pull it back a little bit, and you see we have a range from 0. If I can go all the way to the left, I'll get a 0. Go all the way to the right, I'll get a 123, and I can do it about in the middle, somewhere around your 511, 512. As long as you can get close to that, what you could do at this point is you could hook a multimeter up to that center pole, and you'd be reading around 2.5 volts, because that's the midpoint from 0 to 5 volts. And whenever your analog to digital converter in your Arduino is pushing out numbers like this, it's right in the middle. It's in between that 0 to 123. Well, this is just by way of review. Most people will be familiar with this. Now, but the question is, how can I do something cool with that? Like, how can I use these various programming control structures like the if or the else if control structures to actually exploit this value and do something interesting? Well, it's really simple to do. The first thing you do is just add in an if, and then you'll need a test. So what are we testing? Well, we're going to test analog value against something. Like, say we just need a simple two-way threshold. We want to say that if the analog value is less than or equal to, say, I don't know, around the midpoint, say 511, then what do I want to do? Oh, well, maybe I just want to, just for simplicity's sake, let's just say we want it to print threshold 1 to the serial monitor. Anytime that the analog value that's being pulled in off of that analog 2 pin assigned to analog value, anytime it's less than or equal to 511, we want it to print threshold 1. Well, and then we could close the brackets to the if, and then we could do a simple else. Else, we can serial print line threshold 2. We could have it print that message to the screen. This is just a simple, just binary sort of thing. Okay, so if it's below 511, print threshold 1. If it's above 511, print threshold 2. We can upload this code, see what it looks like. And open our serial monitor. And now it will still be at that 0 range. And notice our analog value is at 0, so I can start to turn the potentiometer. Say I turn it, and I can get all the way up there. See, I'm right here at these 480s. I haven't reached 511 yet, so I'm still in threshold 1. Well, if I go past that 511, see, I'm at threshold 1 while it's below 511. And then all I gotta do is just twist it just a little bit. As soon as I exceed 511, I'm getting threshold 2. So it's working. It's doing that. It's two thresholds. In one case, if we're below the midpoint, we're on threshold 1. If we're above the midpoint, at that 511 midpoint we've set, we're at threshold 2. Simple. So that's an easy way, just automatically, that if you just want a simple what to do when the voltage is around 2.5 volts, do one thing, versus when it's above 2.5 volts, do another, this little if-else control structure will do that for you. But you could just as well do that with a momentary button. What's cool about pulling in these analog values is that, in a sense, you can granulate them as far down as you want to go. And you can have, instead of just 2 thresholds, you could have 10 thresholds, or 20, or 30. And that comes in handy in some cases when you're trying to construct things like view meters or spectrum analyzers, something that's pulling in audio analog values that are really fast, they're changing rapidly, and you want to, parse those values really cleanly to break them over, say, a LED display that has 10 lights or 80 lights or 80 LEDs, etc. And we'll get there. But that's just a simple way to go if and else. Now, but could we do more? Let's say we want to break this across like 10 values or 10 thresholds. Well, I have a program back here that's still the same setup. I'm using a 100K potentiometer. You could just as well use 1K, 5K, 250, or a million K. It does not matter. And I'm just using pin A2. Now, notice that in that previous piece of code, let's bring that back just a second, that it's very common to see in a lot of the initial intro to Arduino stuff is you'll just see an analog read, and you have the simple old analog pin number stuck in here, which is fine when you're doing a simple program. And then it'll be picking up, it'll declare an integer type variable, name it something to catch whatever values are being pulled off of a particular analog pin. Well, that's fine, but once your code gets more complicated, it's kind of nice to have a constant integer type variable associated with this. Rather than going pin numbers just in the raw, you can do stuff like constant int analog pin A2, and then instead of having to refer to A2, we'll be able to use analog pin just as a global variable. It's just kind of nice, and since it's constant integer type, this will, there'll be no manipulation. No code that we write can ever affect this particular assignment. The analog pin name will be associated with A2 regardless of what we do in the code. If we try to change that, the compiler is going to yell at us, let us know, hey, you can't do that. So inside void setup's really just basically the same thing, except a lot of times, like in the previous piece of code, we didn't really declare A2 as input. We just dumped it over, just analog read straight off of it, which you can do. There's nothing wrong with that. But if you want to be really explicit about it, whatever analog pin you're using, whether it's A2 or A0, A5, 6, whatever, that it's not bad practice, especially if you've got a really complicated piece of code and you have toggled this value, to an output input, and you're toggling it inside the code. It's a good idea to at least start out with analog pin, set its pin mode to input, and then if you're going to change it as you go along, at least you're always starting out with it in its input state, because you can digital write to analog pins. So it's not unheard of that sometimes you do that. So sometimes, to me, it makes sense to start out, set analog pin to input. It is there by default when the controller's starting up, but unless you've got another piece of code stored on there, and it may not be. So, it's according to how much you want to rely on whether it's actually going to be in its input state and just assume that, or if you want to actually make it explicit. Either way, we've made it explicit in this piece of code. The next thing, we initiate a serial connection, put a delay, give the connection time to establish. No mystery there. But now in void loop, what are we doing? Well, we're doing the analog read function on that analog pin, which is A2. Then it'll give us a value somewhere, an integer value from 0 to 123. And that value, with the equal sign, will be assigned to the analog value variable, which is an integer type. As soon as we have that assignment made, then we'll print that to the screen. We'll have analog value equals, well, whatever the value that analog read function is assigned to it. That'll print out. And notice these are prints, so this is all going to be on a single line. And then at the tail end of it, we've used this escape with a tab character, which all this does is it'll tab over, just like if you push tab on your keyboard, before the next value gets appended to the back end of that same single line. Now, and you'll see it when we run the code. If you're not familiar with the escape and the tab, you'll see it. It's a nice way, if you're working with a serial monitor, to keep your data kind of organized and tidy, not have it all over the screen. And so now what we've done, or what I've done in this example, is I've just started out with the most basic way. This is not the best or preferred way to do this. It's a lot of extra work for the processor. So it's not the best way to do it, but it's the starting point. Say we want to have 10 thresholds. We want to granulate that 1024, which if you think about it, it's 0 to 1023. Well, that 0 counts. And I mean, when you get down to the nitty gritty, is it a 1 to 123 or 124? Blah. Well, it really, a 1 is not going to make much difference. But so you can go 124, break it into 10. 124 divided by 10 is 102.4. Well, we don't want to deal with that float, that 0.4, so we'll just start with 102. And so the first thing we can do is we can do an if test on the incoming analog value. We can say if analog value that's coming in, if the analog to digital converter, if it's assigning a value to this variable that's in the range of 0 to 102, like it is 102 or below, then what do we want to happen? Well, we want it to print to the screen threshold 1. We'll know that we're inside threshold 1. And in serial print, at this point, you could be turning on your first LED, or keeping all your LEDs off until you hit the next threshold, or whatever you're up to. That serial print is just a stand-in for, you've got this range here that you want something to be done in. And then we can move to the next threshold. We can say, okay, just go up 1 and say, okay, if my analog value coming out of that analog to digital converter, if it is greater than or equal to 103, and the logical and, where both of these would have to be true for this conditional to turn out true, if it's greater than or equal to 103 and it's less than or equal to 204, well, print threshold 2 to the screen. And notice that the 102, there's 102 between there and there. So your range is 0 to 102 for threshold 1. Your range is 103 to 204 for threshold 2. Then you're going to increment by 1, 205. Notice it's just greater than or equal to. That's just you're creating a range from 205 to 306 would be threshold 3 on down the line. I mean, it's just a redundant procedure over and over, and you're breaking up that 1023 into 102 place chunks. That's what this code is doing. And so in the end, you'll end up with 10 thresholds using this piece of code. And so we can see how that works. Let's upload it, get a sense of how this stuff is working. So we upload the code, and we'll go back up here to the top. Threshold 1, as long as our potentiometer value, as long as the value that's being converted from that potentiometer is less than or equal to 102, we should see threshold 1 appear on the serial monitor. As soon as it exceeds 102 and goes 103, but it's below 204, we should see threshold 2, etc., etc., etc. Let's see. Verify. So we started out potentiometers way out there in the middle, so let's go back to 0. So we're at analog value 0. That's the potentiometers at 0 volts. Threshold 1. And so what happens? Let's creep up to that 102. It's kind of difficult to do with a potentiometer, but just kind of ease it into it. See, we're at 99 and 100, and we're still at threshold 1. Our value's coming in. Well, what happens as soon as we hit around 102? There's 101, 102. See, we're still at threshold 1. But see, when it flickers to 103, we hit threshold 2. So we know that that first conditional is working. And so we can push it a little bit further so it stabilizes, threshold 2. Now, what should the next threshold be? How do we get from 2 to 3? Well, here's threshold 2. It says 205 to 306. It'll be greater than or equal to 205, and it has to be less than or equal to 306. So if we go above 306, we should be in threshold 3 as long as we're between these two ranges. So let's see. So we're in threshold 2. So if we go to the 205, 206, we should enter threshold 3. Yep, and we do. So let's see. Just play with it. Just get it right on the edge. Yeah. See, there's your 207. And see, we were in threshold 3 at 207. So that's kind of nice. And to go to threshold 4, all we have to do is keep turning the potentiometer, increasing the value. And as soon as we can cut auto scroll so it's easier to see, we were at 306. Well, when we somewhere in between 306 and 320, we left threshold 3, went to threshold 4. So let's look at that. There's threshold 3. So once we exceeded 408 and hit 409, we entered that threshold 4. So let's verify that. we can do that. Yeah, see, we left threshold 3 when we hit 300, then we dropped into threshold 4. So, and we can kick auto scroll on, and I think everyone will get the message that as you're turning, as that analog value is changing, you're entering and exiting different thresholds. And I have this slowed down with a 500 millisecond delay. But you can take that delay out, and it will actually, from what I read the other day, it would do almost 10,000 samples within a second. So just to get a sense of what something like that looks like. Now, the serial print's going to slow it down. But you can cut out that 500 millisecond delay, upload the code, and click on the serial monitor, and it'll be blazing fast. And so now I can vary that potentiometer, and you see it'll jump in and out of those thresholds. You could be controlling LEDs based off of, if this was audio, it would be moving way faster than these prints can make it from the Arduino to my computer. And so you can control where those LEDs are, you can control the speed of a motor, you can control the brightness, etc., 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 with analog brights. So, but this is just a simple demonstration of how you can use that. You can use analogRead, collecting it into a variable, assigning whatever value is coming in off analogRead, collect it to it, and assign it inside a variable, and then test that variable for specific ranges stretched out from 0 to the 123. You know, I mean, if it's confusing to you, just think of it as 123. It doesn't really matter, truthfully. So now that one off is not going to make any difference in this particular Arduino microcontroller. So that's a way to get 10 tests out of 123 range that you've got coming in. But you could just as well reduce this to, say, 52, and then have this as 53 up to 102. So you could go 20 cuts. You could do 30 cuts, doing, say, a 25-30. If it's less than or equal to, say, 30, then this could be 31 up to like 62 or something. You can keep granulating this excuse me, smaller, as much adjustment as you need based on, or however much you want to be triggering based off of analog value coming in. And this is just using the simplest of control structures, the if test. But now the next question is this really the most efficient way to run through 10 thresholds or 20 thresholds or 30? No, it's not. That in fact, what the processor is having to do with this particular code pattern is it's having to, it asks, is the analog value less than or equal to 102? Well, what happens when it is? Well, it prints threshold 1 to the screen, but then what does it do? Oh, it has to run down and check all these other if tests. So it's kind of like, that's the thing to kind of keep in mind is if says, is this true? Well, given that there's no else's or else if involved, the processor's got to check each and every one of these. It's got to go, is that test true? Is that test true? Is that test true? Over and over and over. And in this void loop setup, that's what it's doing. It's testing each one of these ifs over and over and over. Even though, say, the very first one was true, is printing threshold 1 to the screen, behind the scenes, that processor's still checking each and every one of those ifs. Well, it would sure be nice to be able to just have it, say the first if comes into play, it's true. It would sure be nice if we could get it to ignore all the rest of them. Or say we get 3 in and we find, oh yeah, this one's true. We're doing whatever threshold 3, which is just a stand-in for whatever you would want to happen when this range was coming in off of the analog, or out of the analog to digital converter. That, wouldn't it be nice to stop that? Is there a way to do that? Yes. After that first if, what you can do is just add an else in front of it and go else if. Just append an else to the front of every one of those if conditionals. This is the first thing you can do. This isn't where most will end up in the end, but it is a way to make the code, the execution, just a little more efficient. you know, with a qualification. So we can go down and just add else if in front of all of this. Now, why would we do this? Well, because think about the way that if control structure works. It tests this. This is forcing that Arduino processor to go, okay, is the analog value less than or equal to 102? Say it's not. Well, then what is it going to do? It's going to go down here. Well, then what about this test? Is it true, or is this range true? Is the analog value in between these two boundaries? Well, say no. Well, then it's immediately going to go down to this one. But notice that it's only checking those else ifs when a condition turns out to be false. So say that we start this up and we have our potentiometer at the one, and it just happens to be within that 0 to 102 range. It'll ignore all the rest of these and go all the way to the bottom of void loop and then whip back around and test this again. Instead of having to test this, find out it's true, then it checks this one, oh, well, that one's false, blah, that one's false, blah, blah, blah. Instead of doing all that, once it gets a true on the front end, once the analog value is in between the bounds set in the front of that if and these else ifs, it stops. It doesn't test any of the others below. That's what else if gives you, which is nice. It's a much more efficient way, unless, and here's the qualification, what happens if that analog value coming in happens to be down here? It happens to be threshold 10. Well, that means it will have checked every one of those else ifs on its way to getting to here. It would have had to test every one of them and find out that, lo and behold, all of the above was false, and so this is the very last test. So it still has to go through all of them if it happens that that the analog value just happened to be within this range of sets, of this threshold for threshold 10. So even the else if structure is not ideal, but it's a lot better than just a plain old if. You know, that especially if it happened to turn out that most of the time whatever your project required happened to be in the upper tiers of these tests. Now, but there's a bit. It's not necessarily a better way. It depends. It depends on what way you're thinking about it. And we're going to look at the alternative to using these if and else if structure when we look at switch. But in many cases, just honestly, I have used this particular structure. It's not very pretty. It's kind of ugly. Many times doing view meters, spectrum analyzers, adjusting motor speeds, etc., based off of some incoming analog read value. And it works every time. Now, is it slower or faster than the alternative procedures? Well, it depends on what you have it doing. With old serial print stuck in here, nothing's going to be fast. I mean, serial print, that takes time for that serial message to get sent, received, and confirmed. So, but it's speedy. And if it's a visual display, oftentimes you can use this if and else if structure. And even if it happens to be that your range, the analog value is way down in the bottom, 30 deep, it'll still get there, because keep in mind that the Arduino is running extremely fast. So the if and else if, some people think it's kind of ugly, the readability is not very nice. You can see it. You can type in a comparison of else if versus switch in the Arduino forum. You'll see a lot of people talking about it. And aesthetically, is it pretty? I don't know, but I know it's extremely explicit. That I know by reading this code that if my analog value is less than or equal to 102, I'm going to have this actions taking place. And if that analog value is greater than or equal to 103 and it happens to be less than or equal to 204, this action's that command will be executed. So in terms of just obviousness of what's going on, That's kind of, to me, has always been the advantage of the if and the else if, is it's really explicit, and the code's especially readable to me because I know what those values are meaning. But that may not be the case for someone else that's not familiar with your particular project. And the alternative, the switch case setup, may be preferential in that context. But we'll get to switch in the next video. But I hope this tutorial is helpful. That you can definitely pause at any point in time so that you can copy the code if you want to. I'll make a quit here just for the sake. I'll pause at this point. We can scroll down to I was around setup, so we'll start at the top. There's void loop, and I'll pause so you can pause the video, enter the code into your own Arduino IDE if you want to. We're down here to the 409, so let's scroll to the 409, and you can just pause the video and enter the code into your own IDE and save it if you want to, and that's the end of the program, or the end of void loop. So I hope this tutorial was helpful. It's just real quick, the quick and dirty on how to use analogRead with the if and the else if control structures. And I look forward to creating the next video.